So to answer the question, I have opened the Swiss Literacy Exam 1 data set again, and we're going to use a one-way ANOVA to identify if there are differences in intelligence test scores between children from different socioeconomic backgrounds. So we know we're going to run an ANOVA, one-way ANOVA, because we have 3 groups of socioeconomic status, or SES as we're going to use. So we're going to go to Analyze and Compare Means. This is one of the ways to run the ANOVA, and we're going to select one-way ANOVA. And now that we have the ANOVA box, we're going to put our dependent variable here, which is they're using the time 1 before the intervention as the intelligence test dependent variable, and the groups we want to compare are socioeconomic status, and so that's going to go under the factor field. And then we're going to click on options, and we're going to select descriptives and homogeneity of variance test, continue, and we're going to get the output. So now we're looking at the output, and we can begin to answer the rest of the questions on the worksheet. 1.3 asks, what is the mean for the intelligence test at time 1 for children with low SES? And then we're going to look for medium and high SES. And so those means are here, and you can see they have the corresponding SES level, their socioeconomic level. So you should be able to report those. And the next question is about the variances of the group, the homogeneity. And we can see here that there's a number of different rows here, but the significance is all much higher than 0.05. So there's no statistically significant difference between the variances of the different groups. So then we can move on to the Anova table here at the bottom. Here is the F that was calculated. The degrees of freedom between the groups is listed here on the table. Degrees of freedom within groups, and the overall p-value is 0.009, or you can round up to 0.01. So since our significance level for the ANOVA is less than 0.05, then we reject the null hypothesis, and we determine that there are statistically significant differences between the means of the different groups. So now we know there's a difference between the low, medium, and high group, but we don't know where that difference is. We don't know which group is different from each other. So now we can go ahead and run the post hoc tests. We're going to run the Lsd test, so we can use the window option here to go back to our data editor. And we're going to go to Analyze, Compare Means, the one-way ANOVA, and we're going to keep our settings here, and we're going to click on post hoc, and we're going to run the Lsd test. We're also going to run the Wkst test, and I think I'm going to continue and OK. And so now we get the results of the post hoc tests down here. First we'll look at the Lsd test. So on the Lsd test we have low status compared to medium and high status. Both of these are significant below the 0.05 level. So we do know that there are differences between low and medium, and also low and high. You're going to see some of these numbers repeat here because the table does have some repeating. But then we have our next value, which is not statistically significant between medium and high status. So low is different from medium and high, and then medium and high are not really are not different from one another. And in this column, you can see the number of points that are different between the groups that are being compared on that line. So for the Wkst test, we can look at the same. We can look at the difference in points between, for example, here we have low status, medium status, the difference in points, and it is not statistically significant. However, low and high are statistically significant, and here is the difference in points. And so that is how you determine or interpret the post hoc test table.